Okay, good day. This is Math 140 College Algebra. I am Professor McCulley, and this is the last presentation for the class. Lesson 7-6, Solving Systems of Linear Equations with Matrices. Let's get to it. Today we're going to define a matrix, we're going to find the inverse of a matrix, and then we're going to use matrix multiplication to solve system of linear equations. So first, what is the matrix? The matrix is a data storage device that can be manipulated in different ways to solve problems involving many numbers at the same time. Matrices are the plural of matrix. Now we're going to use them to solve systems of linear equations, but matrices are used a lot in statistics and probability. Whenever you have lots and lots of data, it's very easy to put it into a matrix. It's a data storage device, and you can manipulate that very easily with a calculator. So in most instances, then anytime you're going to use a matrix is if you have a calculator, but it is a good idea to just have a general idea of what's going on in the calculator. So if we want to talk about what a matrix looks like, a matrix usually has brackets around it, and then it has a set of data in it. And that data is organized by rows and columns. So this matrix has 2 rows and it has 3 columns. And we would call that a 2 by 3 matrix. So the numbers here are the rows by the columns. Each element of the matrix is in a cell of the matrix. So the 1 is in the row 1, column 1 cell of the matrix. And those cells, as I just said, are designated by an ordered pair corresponding to their row and column. We will see that when we type these in the graphing calculator, and I will stop to show you that. The inverse of a matrix. Most operations have inverses. Addition has subtraction. Multiplication and division are inverses. Square and square root are inverses. To find the inverse of a matrix, what we're going to do is we're going to use this X inverse button. And so if I pull up my graphing calculator and I come over here, you'll notice that right above, if I look at the 7, I go up to the x squared, and then above that I have this x, what looks like to the -1 power. We're going to call that the X inverse. Excuse me. We're going to call that the X inverse button. And then the second feature of that is the matrix menu, and we'll do all of our entering and manipulating of matrices using that particular menu. All right. So the notation for finding the inverse of matrix A is just to go put your matrix or your capital letter with the brackets around it, and then put that -1 as a superscript there. And then whenever you find or asked to find the inverse, you're probably going to want to use the fraction function, because inverse matrices usually have fractions for their answers, especially if you have whole numbers. And the reason for that is in this particular slide, if we want to find the inverse of a matrix, of a 2 by 2 matrix by hand, if we're given a 2 by 2 matrix, A equals A, B, C, D, and again, you read your matrices rows and columns, and you read right to left and then down, or excuse me, left to right and then top to bottom, just like you would a book. But the inverse is defined by taking 1 divided by AD minus BC. And when I say AD, I mean this AD and this BC. And then they take this A and this D and they switch them. And then they take the B and the C and they make them negative. All right. Now you will not be required to find a 3 by 3 matrix by hand. That process is rather involved and takes probably 3 or 4 more steps. This is pretty simple, but this one is significantly harder. But let's do an example. If I were to ask you to find the inverse of 1, 2, 3, 4 by hand, um, the inverse of matrix A is, remember, it is AD minus BC, and then it is D and then A, and then B made negative and C made negative. All right. And so what I want to do here is I'm going to go 1 over, well, AD will be 1 times 4 minus BC, well, that'll be 2 times 3. And then I need to go 4, and I need to go 1. I'll switch my A and my D, and then I'll make that 2 negative, and I'll make that 3 negative. And so Um, 4 minus 6 is going to be negative 1/2. And then 4 minus 2 minus 3, 1. And so I don't necessarily like to call it distributing, but when you multiply a matrix by a scalar out front, you just multiply each element of each cell by that scalar. So this is going to become negative 1/2 times, I'll just write it out, negative 1/2 times 4, and then negative 1/2 times negative 2, and then negative 1/2 times negative 3, and then negative 1/2 times 1. And so our final answer here will be negative 2, positive 1, positive 3 over 2, and then negative 1/2. So you'll notice that I have some fractions in there. And so that is A inverse. All right, solving systems of linear equations from lesson 7.5. We took 3 sections to talk about substitution, row reduction, graphing of linear and nonlinear systems. Now we're going to use matrices. The one thing that these matrices will not do is it will not find parallel lines and it will not find the same line. So if you get an error when you do this process, you know it's very likely to be one of these two things. It's either parallel lines or the same line. All right, so solving a system of linear equations, the first thing you want to do is you want to make sure that you've got it set up in general form so that you have all of your variables on one side and all of your constants on the other side of the equation. And then we'll break it up into what I call the coefficients matrix and then the constants matrix. All right, so A is my coefficients, 5, -1, 4, -4. And this second matrix is the constants 9 and 2. And so what we're going to do is we're going to actually put this in our graphing calculator so we can see how to do it. So I'm going to go to my y equals. I'm going to go second, and then I'm going to hit that matrix button. And your calculator actually will keep more than 9 matrices, but first thing we want to do is we're going to come over here and we're going to edit them. So I'm going to hit edit 1. Now I already have a 3 by 3 matrix in there, but that's not what I want. So I need to enter a 2 for that first, for the number of rows, and then I need to enter a 2 there for the number of columns. And we see that the calculator has updated that for us. So I need 5, -1, 4, -4. So 5, -1, 4, -4. I want to make sure I hit enter, because if you don't hit enter, it may not change that last value, and you could get an error because you didn't change that last value. So now we're going to go second, we're going to go matrix again, and now we're going to go over to edit, and we're going to edit that second one. And this one we want to be a 2 by 1. And then we're going to add the values. So the values were 9 and 2 for our constants. So 9 and 2 there. And so we're going to hit quit. And so now all we have to do is go A inverse B. So let's do that. So second matrix, we'll hit the A button. That'll bring that up. Hit the X inverse button. And we'll go second. And then we'll go B, and we'll stay in names, and we'll hit enter. And I needed to hit fraction, so we'll just hit math, and we'll hit fraction there, and we'll get, and so we get this 17 over 8 and this 13 over 8. So what does that look like? Well, 17 over 8 and 13 over 8, since we lined up the x's here, the x will come on the top of our solution. Since we lined up the y's second, the y will be the second value in that. All right. And so again, since this is a solution to a system of linear equations, our final answer is going to be an ordered pair. Now, this system will also work for systems of linear equations in 3 variables. And we remember from the last section that if you have 3 variables, you have to have 3 equations. Now, I picked this one to point out here that this one has no z term. So when we set up our matrices, what we're going to do, especially for our coefficients matrix, what we're going to do here is we'll get those coefficients. For this first one, it'll just be 4, 3, and then 1. And then this second set, we'll go 6 and we'll go 1 for the x and the y, and we'll put a 0 in as a placeholder for the z value. And then on the last row, we'll go 3, 5, and then 3. We'll make ourselves a constants matrix, and that constants matrix will be 14, it'll be 9, and then it will be 21. And so we'll grab our graphing calculator, we'll go math, we'll go matrix. Oops, I need to go second and then matrix. There we go. And because I'm going to want to use these again, I'm going to actually make a C and a D. So I'm going to hit 3 for C, and we're going to change this to a 3 by 3 matrix. And then I got to copy the values. So 4, 3, 1, 6, 1, 0. That's about all I can remember. 4, 3, 1, 6, 1, 0. Oh, and by the way, you do notice that I did say that I talk about how we label the ordered pairs. So this thing right here says matrix C, row 2, column 3 is the contents of that cell is 0, and that's what I have in there right now. Okay, so in the last row, we're going to put 3, 5, 3. And then we're going to go second. Well, at matrix, we'll go over to edit, and then we'll hit 4, and we'll enter the values that are there, and they are 14, 9, and 21. So 14, 9, 21, we've got that. So we'll hit quit. And now we're going to do the same thing we did. We're going to do that A inverse B, but this time we're going to go second matrix. And because we put the values in 3 and 4, we'll hit 3. We'll hit that inverse, we'll hit second, we'll hit matrix, we'll hit 4 this time, hit enter, and we get 1, 3, 1 as our values. So if I go the inverse here, we're multiplying, our result is 1, 3, 1, and our final answer is going to be 1, 3, 1, and ordered triple. All right, so let's talk about how we would do an example. Sumali and Eduardo each improved their yards by planting hostas and ornamental grass. They bought their supplies at the same store. Sumali spent $126 on 9 hostas and 11 bunches of ornamental grass. Eduardo spent $27 on 3 hostas and 2 bunches of ornamental grass. What is the cost of 1 hosta and what is the cost of 1 bunch of ornamental grass? Now, this sentence right here tells us what the variables of this particular problem are. All right, because that is what it's asking us to find. So I'm going to say H is the cost of 1 hosta, and B is the cost of 1 bunch of ornamental grass. Oh, gee, that sounds like a good idea. All right, so let's set this up. All right, so Sumali spent $126 on 9 hostas and 11 bunches of ornamental grass. So if we're trying to find the cost per hosta. So if I had 9 hostas and I multiplied by the cost per hosta, the units would cancel out and leave me money. So we're going to go 9H plus 11B, and that's going to be equal to 126. And then we'll go 3H plus 2B gives me 27. And so that corresponds to this first statement and this second statement. And from that, I'll set up my matrices. I'll go 9, 11, 3, 2. And then on the second one, we'll go 1, 26, and 27. And since I already have a 2 by 2 and a 2 by 1 set up on my matrices, I don't have to do that. I just can go over to edit, and I can edit 1, and we can change those values. let's see here. They were 9, 11, 3, 2. I think I remember that. So 9, 11, 3, and then 2. And then we got that in there. So second matrix, go over to edit. We're going to hit 2. Hit enter, get down into our list there, and we'll go 126, and we'll go 27. Second quit. So here we're going to go second matrix. We're going to hit 1 to bring up A. We're going to hit that inverse button, second matrix, hit 2 for B, and we get $3 and $9. And so, so if I go inverse times, I get 3 and I get 9. Now because I put H first, $3 per hosta and $9 per, should be cost, per bunch of ornamental grass. Our final answer. Well, that's all I got for the class, folks. So the last Marvel fun fact of the day in WandaVision from 2020, the Vision and the Scarlet Witch have twins. Since the since the Vision is an android, this would seem kind of impossible. The comics explain this by saying that Wanda is so powerful that she warped reality and willed the twins into being. And I think this is a mistake here. I think that should be Wanda is, but this is the last one, so you can forgive me that simple mistake. Have a good day, folks. Goodbye.